Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. We're still continuing with our financial mathematics series, and today we'll be talking about loan prepayment or curtailment, or better known as a principal reduction. And take note, this is part 10. Make sure to check out all the other parts prior to this part. Now, these are terms that are used to refer to an additional but partial irregular payment made to reduce a loan balance which may reduce the interest costs. So at times, these terms, loan prepayment, curtailment, principal reduction, can be used interchangeably. So ideally, a loan, let's say L dollars, at an interest rate of R% per annum compounded I periods or a period a year for N years. If we are going to represent that payment using a timeline, we would have something of this nature where at time zero, you get a loan worth L dollars. And then you are expected to repay back the loan after N years. So there is a process of repayment. So after N years, the loan's value will be worth something simply because it would comprise of the interest. So I know that this channel is a mathematical channel, but I saw it fit that we cover some of these concepts. So in this session, we are basically going to talk about the terminology used and also, of course, the formulae. However, we are going to cover some examples in the following sessions. So it is important that we get everything right and we also master the terminology starting from the grassroots so that when we come to the examples, we know exactly what we are dealing with. So now with that, we know that the value of the loan, that is after N years, will be worth LV. That is to say, using the formula, the value of the loan will be L, the original or the principal loan, times 1 plus R over I times N times the periods, number of periods. So that would give us the value of the loan. And I encourage you to check out all the other parts, especially prior to this one, part 8 and part 9, where we covered the use of this formula. This is going to be crucial and beneficial so that we understand the loan, not just in the current moment, but also when it is due, because we also need to know the value of that particular loan when it is due. However, if there is an additional amount repaid, say for instance, P1, after T1 periods, in order for us to clear the loan to reduce the interest costs, then we may need to consider the timeline. So we are going to have two methods that are going to be crucial in understanding how this idea of paying an additional amount in order to start clearing the loan prior to the day it is due, because in so doing, we reduce the interest costs. So what happens is at the end of the period the loan is due, we would incur less interest costs. So method 1, we are saying that we have the loan L at time 0, which is going to have a certain value when it is due at time t. That is to say, t would be the number of periods. So not just the years, but the periods times the years, because that would give us the total periods. And at the end of the total period, this is the time when the loan is due, we are going to have the value of the loan being LV dollars. So if we make a payment at time T1, rather, I wouldn't want us to look at it as time, but period, because it could be 3 months. If it is, say, a loan that is compounded monthly, the interest rate per annum. So we are going to have it perhaps as anything. So T1 here would be the period in which we decide to pay an additional amount so that we try to reduce the value of the loan when it is due so that we also incur less interest costs. So if we pay P1 in order to sort of reduce the value of the loan, we are going to also have that amount that we have paid being worth something at the end of the time the loan is due. That is to say that P1 after the T periods, we are going to have that having its own value. So meaning that it would actually reduce the value of the loan at the time it is due. So now that is what we have over here. So in this timeline, we see that P1 would also accumulate some interest in as much as it was just worth P1 at the time it was paid, but it is going to accumulate interest up until the time the loan is due. So meaning that the balance of the loan to be repaid, let's call it BV, is going to be LV, which is the original value of the loan at the period when it is due, minus the payment value. So the payment value comes from the payment we made in between the periods P1, which is going to accumulate some interest so that we get the value, the balance of the loan being less than that which it was supposed to be. So now if we consider the formula, we are going to have, so we know for LV is given to be L times 1 plus R over I raised to the power NI minus the payment value. So we paid P1, but that P1 is going to accumulate some interest for the period that is left. So that's why we have NI. So that NI can actually be the capital letter T minus the T1, because we know that our payment would not accumulate interest from the time the loan was given, but from the time it was paid. And remember, we paid it in between after the loan had been given to us. Right, so that is the formula that we would have that would give us the balance that is due. So that is the first method. Now, when it comes to the second method, so both methods would take us to the same thing. However, we are saying that each and every method works a little bit differently, but it's the same thing. So now for the second method, we get the loan at time 0, and that loan would be a loan that would keep in mind for now, knowing that at time T1, we make a payment that is meant to clear the loan. So not really clearing the loan, but to reduce the value of the loan. So in our case, we are going to have the balance at T1. So we know that the loan that was issued was worth L dollars, but up until the period T1, the value of the loan would accumulate. So the loan would accumulate interest up until T1, and at T1, we make a payment. So that is going to reduce the value of the loan at T1. Then that particular value of the loan that is left would accumulate interest till the end of the period T. So that is the logic that we're using. Therefore, the balance of loan to be repaid, BV, is going to be LV1, that is to say, the value of the loan at time T1 minus the payment that we made at T1, because that is the value of the loan at T1. So we subtract at T1, we get the value of the loan that is left, or the balance of the loan. Then with that, we are going to find what it will be worth from T1 to T. And then we are going to just multiply with the interest. And take note, 1 plus r over I raised to the power ni minus t1, because this is the value from the time we make the payment up until the end, or when the loan is due. So that is how we would get the balance to be repaid. So in a nutshell, if we are going to substitute for the LV1 and the P1, we know that P1 is that same amount. There's nothing that happens to it. We just have it as P1. But the LV1, which is the value of the loan at time T1, is that which we have there. And take note of the time, T1 times I, because we are saying that the period times, rather the years times the periods. So we can have it as just T1 instead of T1 times 1, because it's the number of periods that we have. Then that would be what would give us the answers that we are looking for. So stay tuned as we look at some examples that will help us. Let's take a look at example 1. So at the beginning of 2025, Jim borrowed $10,000 at 10% per annum, compounded monthly. After 3 months, he made one payment of $3,000. How much will he need to pay to settle his debt at the beginning of 2030? So the first thing to note is that we have to find out all the parts that were given, or rather the components of the formulae that we are going to use. So for instance, we know that n, which is the number of years according to our formula, is given to be 5 years. The I, this is the compound period. This is 12 months in a year, so we will have that as 12. And of course, the interest rate is given to be 0.10 in decimal form, which is basically the 10%. Now, so we will start with method 1. So with method 1 here, we see that at time 0, we have $1,000 that is being borrowed, or rather $10,000 that is being borrowed. So with that $10,000, we see that after 3 months, Jim decides to pay $3,000 in order to reduce the value of the loan. And take note, this is 3 months, so that is the period, and the amount that is paid is $3,000. Therefore, that $3,000 is going to mature with interest and be worth something in the near future, implying that the period it will take from time 0 to the time the whole loan is due is 5 years times 12 months, which would give us 60 months. That is the total period that is required for the loan to be paid back. Now, the balance of the loan is going to be given by that LV minus payment value, and we know that LV is the value of the loan at the time when it is due, the 60 months. So we will start by looking at the formula that we have for method 1. So we know that LV is that, and the payment value would mature, and it will mature from 3 months to the 60 months. Then we are going to substitute for each and everything that we have. Therefore, the balance of the loan to be repaid is going to be, considering the value of the loan itself, we substitute. So the L is the value of the loan at time 0, which was just 10,000. So we're going to have 10,000 times 1 plus, and recall, our interest rate is 0.10 or 10%. And we divide that by the compounding period, which is 12 months, or rather 12 times in a year. So remember, the periods are the number of times this is compounded in a year. Then, because we are looking at the loan itself, the loan will run for the whole period from time 0 or period 0 to period 5 times 12 months, because we're saying that in 5 years we are going to have 12 times in which it is compounded in a year. So that by 5 would give us 5 times 12. So in a year it's compounded 12 times. Then in 5 years in total it will be compounded 60 times. That is the value of the loan itself. However, we know that Jim paid an amount in order to reduce the value of the loan before it was due, and that would help because it means that Jim is not paying only $3,000, because after the certain number of periods left, that would accrue some interest that would actually help in reducing the balance of the loan. So we know that Jim, at time, or rather the period 3 months, Jim paid $3,000, 1 plus. So the interest rate is still the same. So we are assuming that the interest rate is the same from the time the loan was given out and the time the loan would be due. So we would use the same interest rate, 0.10 in decimals. Then we divide that by the periods, which is 12 in a year, all raised to the power. So 5 times 12 minus 3 months. We are doing that because we know that the payment would acquire some interest from 3 months to the end of the periods it is due. So that 3,000 is not acquiring some interest from time 0 because it wasn't paid at time 0. And of course, it is advisable to simplify our work. So you can start by simplifying what's inside the parentheses. So when you do so, you raise that to the power that results. So step by step. And it's important to know how to use our calculators, get used to our calculators beforehand, so that when we are dealing with these kind of questions, it could be in the examination setup, we have an idea of how to use our calculators and also avoid unnecessary mistakes. Now with that, we are going to end up having that bit there. And we see that the powers, the first power, 5 times 12 is 60. Then the 5 times 12 being 60 minus the 3. Then of course, inside the parentheses or payoff brackets, we have 1 plus 0.10 divided by 12. That could actually be expressed as a fraction, 1 over 120, but you don't need to do that. You can just punch into your calculator straight so that you get your answers directly if you are confident of your skills using the calculator. But if you don't, there is no harm in simplifying your work into bits and pieces. So you start by what's inside the parentheses or the brackets. Now we see that we can actually combine the fraction and the whole number that we have within the parentheses, so that we have 121 divided by 120. Then of course that is raised to the power 60, and that one raised to the power 57. So with that, then we can find the values of the figures, the terms that we have that are raised to the power something. And for the first one, we are going to have 121 divided by 120 raised to the power of 60, giving us 1.6453. That would be the value that we would have. And take note, when it comes to rounding up, I would suggest that we stick to either 4 or 5 decimal places and not anything less than that, because in as much as we know that the answer rounded up to some significant figure, it will be the same. However, we know that small changes that we may have on the significant figures may actually change our answers. So 4 to 5 decimal places would be ideal. So in the next bit, where we have to the power 57, we would end up having 1.60485. So now this is now simpler to multiply. So when we multiply with the 10,000, the first part, we are going to get 16,453. This one did not have cents. Then when we move on to the one that we are going to multiply with the 3,000 with, we are going to get $4,814.56. This is because when we multiply with the 3,000, the comma was shifted a number of times so that we have the cents there. Then, of course, simplifying this one here would then give us our final answer of $11,638.53. So that will be our answer. So I encourage you to make sure that as you are working on such kind of problems, yes, you might know the formula or formulae, but if you don't know how to properly use your calculator and compute these values, you may tend to get wrong answers. This is from experience, and I've seen it with a number of students. So make sure you try to simplify things and take things one step at a time up until you get to the final value. And another thing that I would stress out is make sure you stick to 4 or 5 decimal places. In that way, you'll be safe so that your answer is not that much different from the expected answer. If you can keep it exact, use exact values. We try to stick to exact values by combining those into fractions and dealing with fractions. That's one way of preserving our values exact. So if you don't have an idea of what exact means in this case, I'd encourage you to check out our video that we have on square roots, surd roots. We talk about exact values. Right, so we are going to be looking at method 2 to the example that we have. So we would take note of certain aspects before we jump into our method 2. So we have to take note of the number of years, which is 5 years, the number of periods, 12, and the rate, interest rate, that is, and that is 0.10, which is equivalent to 10%. So note, with method 2, unlike method 1, where we had to shift everything to the final period, then find the difference between the values. In method 2, we are saying that when the first payment is made towards reducing the value of the loan, we consider that. That is to say, the loan that was given was 10,000. Now at time T1, so our T1 is 3 months. So that is something that we have to be aware of. So this is 3 months. So with the 3 months over here, we know that that loan would have accumulated some interest in the 3 months. So we are going to get the value of that particular loan in 3 months, then subtract the payment that was made. So that is basically what we are talking about. So now, in order for us to get what the value of the loan is in 3 months, we are going to find LV1. So let that represent the first payment. So the 1 is for the first payment that was made. So we do have cases where we have multiple payments actually, but in this case, we just have one payment, so we'll stick to that. So let's call this one LV1. That is to say the loan, the value of the loan at the first payment in order to reduce the loan. So we need to find the value of the loan at that particular period. So LV1 will be given by the loan itself, 10,000 times 1 plus 0.10 divided by 12. So the 0.010 is the rate, and the 12 are the periods that we have in a year, and also the 3 would be the period in which it takes to clear, not clear, but in order for the payment to come through. Yep, I think that is how I would put it. So with that, we know that we would need to simplify what's inside the parenthesis. So inside the parenthesis, this expressed as a fraction would be 121 divided by 120 raised to the power 3. So I would encourage you to deal with what's inside the parenthesis first so that you avoid making unnecessary mistakes. After that, then you multiply or you raise it to the power 3, then multiply with the 10,000 so that you get the answer to be $10,252.09. This means that this is the value of the loan after 3 months. So now that we have obtained the value of the loan in 3 months, we see and know that in the 3 months, a payment came through that was meant to clear the value of the loan. So that happens, implying that the value of the loan at that particular point, 3 months, is going to be LV1 minus P1. P1 is the payment, and LV1 is the value of the loan after 3 months. So we find the difference between the two times the interest that will be accrued from 3 months up until the end of the periods where the whole loan is due. So we know that the period here, since we're calculating from the 3 months, so we are going to subtract 3 months from the time the loan is due. Substituting for LV1 that we obtained earlier on, we are going to have the $10,252.09. Then the payment was 3,000 times then that which would generate the interest compounded monthly. So we would have that bit over there, and of course substituting for the n and for the I, which is 12, we are going to get that. And I would encourage you once again to deal with what's inside the parentheses first. So dealing with the LV1 minus P1, the 3,000, then multiplying with what you would get inside the second set of parentheses raised to the power 60 minus 3, which is basically 57. Then with that, then we are going to end up having something of this nature. So $7,252.09. And then we have that bit, which is the second parenthesis, 121 divided by 120 raised to the power 56. So I'm doing this because I want to keep my values exact. So the more exact your values are, the better your answer comes out. So it wouldn't be different from somebody who used a software to solve the problem, because you would know that in some exams, in some instances, some values are calculated using some software which are exact. So each and every calculation is exact. But if you start rounding up your answers prematurely, it means that even your final answer would end up being compromised and becoming slightly different, if not much more different from the one that is expected of you. So you wouldn't want that to pop up in the exam. So try to keep your values as exact as possible. Right, so simplifying further, we are going to end up having $11,638.54. Now take note, I rounded prematurely over here, and my answer is slightly different from method 1. In method 1, we had 53 cents. However, it is worth noting that in many instances, what does happen is that the answer becomes totally different. Yes, some may say, of course, if we round our answer up to some, say, 2 or 3 significant figures, the answers will still be the same, but at times that wouldn't really work. So it's important to keep your answers as exact as possible. Then this will be how we use method 2 to solve such questions. Let's consider example 2. A loan of L is repaid in the manner $2,000 after 2 years, $1,500 after 1 year, and L divided by 2, 3 years after that, and a final amount of $3,000 another 4 years. So we are told also that the compound interest is 18% per annum and compounded monthly for the first 5 years and 19% per annum annually for the last 5 years. Calculate the initial amount of the loan. We will look at method 1 for our solution. So it is important to take note of everything that we are given. So the first thing is the loan itself. So the loan itself is given, and that loan is L at time 0, and that loan is going to mature after 10 years. The second thing is, we know that after 2 years, there was an amount that was paid in order to reduce the value of the loan. So that 2,000 is going to accrue some interest, so that at the end of the period, the 10 years, that 2,000 is going to help in clearing the loan. In the third year, we also see that there was an amount that was paid of 1,500. That is also going to acquire some interest and help out in reducing the value of the loan, or rather the balance that is left of the loan. Then after 5 years, this time around, we have to take note of the change that takes place in the interest rate. So this example sort of represents a realistic situation that you may face in life. Then also taking note, in the 6th year, we have L divided by 2 payment that was made, and that is going to also accrue some interest that will help out in clearing the loan. And finally, in the 10th year, when the whole loan is due, an additional or final payment was made of $3,000. So with that, we are going to consider the first 5 years. This is important because in the first 5 years, the rate that was used is different from the rate that was used in the last 5 years. So in the first 5 years, we take note of the loan itself. So the loan was L. So L times 1 plus the rate. So the rate is 18%. So we express it as a decimal according to the formula we're using. That would be 0.18 divided by the periods per year in which the interest is compounded. And if it is compounded monthly, what it does or means is that it is compounded every 12 months in a year. So that is going to be divided by 12. Then we know that in the rest of 5 years, we are going to have 5 times 12 periods. That is to say, in each year we have 12 periods. Then in 5 years, that will be times 5. So now, as before, I would encourage you to make sure that you simplify what's inside the pair of brackets or parentheses. Try to keep it as exact as possible so that you are able to get the exact value, or a value that is close to the expected answer that you would have finally. Right, so inside the parentheses, we see that that can actually be simplified to 1.015, and that will be raised to the power 60. Of course, we could have just evaluated that, but remember, our goal is to keep our values as exact as possible, because we do not want to compromise on the final answer that we would have. If we start rounding up prematurely, it would mean that even our final answer would be an answer that is a bit different, and in some instances, it will be so different from the one that we are expected to get. So that is the value of the loan after 5 years. That is the first 5 years. Now we consider the value of the loan in the last 5 years. We see that the loan has acquired some interest in the first 5 years. That's why it is now L times 1.015 raised to the power 60. Then in the last 5 years, the interest rate changes. So now as the interest rate changes, it means that what we have up until the first 5 years would also accrue some interest for the next 5 years, but at a rate of 0.19 expressed as a decimal raised to the power 5 because we've got 5 years, and this is compounded annually, so meaning that the period is once a year. That's why we just have 5 or raised to the power 5. So we multiply the value of the loan after 5 years times the 1 plus 0.19, which is the interest in the last 5 years, compounded annually, and that is 5 times in total. Therefore, we move on to simplify what we have inside the parentheses so that we have L times 1.015 raised to the power 60 times 1.19 raised to the power 5. Then, of course, if we want to perhaps simplify things, we may evaluate this. So that would give us 5.8304 L. Now, considering the payments made to clear the loan, so we are going to use the same approach. We have now the value of the loan after 10 years that we obtained. Now we consider the first 5 years. And considering the first payment was made in the first 5 years, implying that the interest rate that is going to be used for the first payment in the first 5 years or within the first 5 years is 0.18 in decimals. And we know that this one is compounded monthly. Therefore, we are going to have the 2000 times 1.015, and this is where we have added 1 with 0.18 divided by 12. We simplified that to get 1.015, the same as the one that we obtained for the value of the loan in the first 5 years inside the parentheses. And now we see that this payment was made 2 years after, implying that in the first 5 years, what we would have at that rate is only 3 years. And in 3 years, the total number of periods we would have is 3 times 12. Each year would have 12 periods. So in 3 years, times 3 that. So we get the value in the first 5 years of the first payment. Then we take that value over to the second 5 years or the last 5 years. We know that in the second 5 years, the rate changes to 0.19 compounded annually. Therefore, that which we obtained in the first 5 years is going to have some interest for 5 years. And that is being multiplied by 1.19 raised to the power 5. And now what we have is what we added, and that is similar to what we obtained in the last 5 years for the loan itself, where we added 1 plus 0.19. Therefore, simplifying that, we are going to get $8,157.22. We move on to the second payment that was made. So in the second payment, we have 1,500 times the 1.015 raised to the power 2 times 12. This is because it was paid in the third year, and at that particular interest rate, the value that was paid, the payment that was made, would be within the first 5 years for only 2 years, and that being compounded monthly. So we are multiplying that by 12, the 2 times 12, so that we get the value of that particular payment in the first 5 years. Then in the last or second 5 years, when the rate changes, we take the value of that particular payment, we multiply it with the 1.19 raised to the power 5, because that is the interest that it would accumulate in the last 5 years. So evaluating that one, we are going to get $5,116.95. Right, so we move on. Before we move on to the next payment, we see that the rate changes, that is beyond 5 years, because we're saying that after the 1,500 payment, there was no other payment that was made in that particular period, the first 5 years. Now we move on to the second 5 years. So in the second 5 years, the payment that was made was L divided by 2. And because it was made in the 6th year, what was left was only 4 years into the period that was considered into the 10 years. So that would imply that we are going to have 1.19 raised to the power 4, the 4 years that were left. And because this was compounded annually, so this one is less complicated than the other calculations that we had to make. So that would give us, when simplified, 1.002p. Right, so then we get to the final payment that was made. Now the final payment is 3,000 and it was made right when the loan was due. So this one is not going to accrue some interest. It would be 3,000 because it was paid on the spot when the loan was due. So if that is the case, then it would mean that the value of the loan in 10 years is equal to the value of the payments in 10 years, because that's how we can find the value of this loan that was given out. Right, so we know what the value of the loan was. The value of the loan was 5.8304 L, which is equal to the sum of all the payments that were made. So these payments are going to have a certain value at the end of 10 years because they also accrued some interest. So we have the first, the second, the third, and the fourth payment. So that is what would give us the value of the loan at that particular time in 10 years. Now that we have that, we move on to solve for L. So if we move the 1.002 L to the left-hand side, we are going to have 4.8284 L is equals to $16,274.17. And of course, since we are trying to find the value of L, L becomes $3,371, and that will be our final answer. A note, this is just one method of solving it. There are many other methods of solving this. So stay tuned so that you don't miss out on any of the methods that we are going to use in solving such questions. Let's look at example 2 once again, but this time around we are going to use method 2. So in place of L, I'll substitute that L with the P so that we differentiate between method 1 and method 2. Right, so we still have the same question. It's only that we have P in place of L. So a loan of P is repaid in the manner 2,000 after 2 years, 1,500 after 1 year, P over 2 3 years later, and of course a final amount of 3,000 another 4 years later. So compound interest is 18% per annum monthly for the first 5 years and 19% per annum annually for the last 5 years. So calculate P, the initial amount of the loan. Right, so we see that from this information that we're given, we have the value of the loan being P at the time 0. But now that loan is going to accumulate some interest after 2 years. So we would need to know what the value of that loan is in the first 2 years before the payment is made, or when the payment is made, because in so doing we are able to see the balance of the loan. Right, so we see that after 2 years the payment is made of 2,000. Then after the 2 years there is another payment that was made on the 3rd year, and that is 1,500. So we see as well that in the 5th year there was a rate change or change of interest rate. and also how it is compounded. So in the first 5 years, we know that the interest rate was 18% and compounded monthly. So implying that our I, which is the number of periods in a year, is 12. But beyond 5 years, we have a different interest rate of 0.19 expressed as a decimal, and that being compounded annually. Then in the 6th year, we have a payment of P over 2 that was made. Then so it implies that basically that each and every time a payment is made, we would need to see what the balance of the loan is. Then we subtract with the payment at that particular time up until we get to the final period, which is 10 years. And in the final period, an additional amount of 3,000 was made, which cleared the balance of the loan. So now this is a different method. It's different from the one that we looked at in method 1. Right, so the balance of the loan after 2 years, we would need to get what the value of the loan is in 2 years. So we have P at time 0. So with the loan that it accrues in the second year, we are going to multiply that by 1 plus 0.18 divided by 12 raised to the power 2 times 12, because we've got 2 years and we've got 12 periods within a year. Then we are going to subtract the value that was made, because it is actually reducing the value of the loan. Therefore, simplifying further, we are going to have P times 1.015 raised to the power 24 minus the 2,000. So with that, we can see that that would be the value of the loan, or rather the balance of the loan after 2 years. Now in the 3rd year, we can also calculate the value, or rather the balance of the loan after 3 years, because we're saying that from the balance that was left in the first 2 years, which accumulated interest for 1 more year, when the second payment was made of 1,500, we are going to subtract that from the balance that was left in the previous year. Right, so that's why we have a 1.015 times 1 times 12. That is for 1 year. So it means that the balance that was left in year 2 has accumulated some interest. And now at that particular time, that is the time we reduce the balance of the loan. So we subtract 1,500 from the balance of the loan. Right, so we see that in the 5th year, things change. The rate of change changes. So we need to calculate what the balance of the loan is up until the end of the 5th year, because beyond that, we would be using a different interest rate. So from year 3 to the end of year 5, that is equivalent to 2 years. Then we are considering the balance that was there for the loan in the 3rd year, which is that chunk that we have over there inside the first set of parentheses or brackets, ending with minus 1,500. Then we multiply that one by the interest that it acquires or accrues, that is accrued, of 1.015 raised to the power 2 times 12, because we have 2 years and the interest was compounded monthly, and that happens for 2 years. So that is the balance at the end of 5 years of that particular loan. Right, so now that we have the balance of that loan after 5 years, perhaps before we move on, we can expand the brackets so that we have maybe something that is reasonable and pleasant to look at. So when we expand the parentheses or brackets into each and every term, we see that that 1.015 is going to multiply with the minus 1,500 raised to the power 24. We have the same multiplying the 2,000 times 1.015 raised to the power 12. Now with the laws of indices, that would give us to the power 36. And the same would go for the first part. P times 1.015 would end up being to the power 60 because we add the powers. Remember from the laws of indices, and I encourage you to check our video on laws of indices if you have no idea of what we are doing here, because that will be beneficial. So when we are multiplying the sum terms, we just add the powers. That is what we learned from indices. Right, so beyond the 5 years, we have the rate or the interest rate being 0.19 as a decimal per annum and compounded annually. So if that is the case, then we see that in the 6th year, to be precise, a payment was made of P over 2. So now that payment is being made on a balance that we obtained in the previous step times the 1 plus 0.19, because from the end of the 5th year to the 6th year, the balance that is left is the one that we obtained from the previous step times the interest that is accrued for 1 year, that is given by 1 plus 0.19. And then because there was a payment that was made of P over 2, we subtract that so that we get a new balance. So now when we subtract that, we are going to get the final balance being something that is given in that way, because we're saying that after the 6th year, we are going to find what interest is accrued at the end of the 10th year. So that is 4 years later. That is to say that whatever we had in the previous step in the 6th year, we are going to multiply that by 1.19 raised to the power 4, because it's 4 years up until that balance accrues some interest. And at the end of that 10 years, the last payment is made of 3,000. So that's why we are subtracting the 3,000. And take note, the 1.19 raised to the power 4 only affects what was in the previous step, because that is what accrued interest, or the balance that we got from the previous step. Then we subtract the 3,000 so that we equate that to 0. The logic is this: if we had made sufficient payments, that would reduce the balance to 0, or totally clear the balance of the loan. So that is what we are using. That is the rationale. So now that we have this huge equation, we are going now to simplify further so that we get to where we want to get to. So I know perhaps it might be an issue for some to know how to go about this. The easy approach would be to divide throughout. But before we divide, let's move the 3,000, because it's negative, to the right hand side so that it becomes positive. As it is positive, we divide now by 1.19 raised to the power 4. So that would clear the 1.19 raised to the power 4 of the interest that is accrued in the last 4 years. Now with that, we can actually now focus on the parts that are remaining on the left hand side. So it is advisable that we try to keep our answers as exact as possible, but there are instances and times where we cannot keep them as exact as possible, like in the case of the P. So the first P, we would just compute whatever we have here using calculators, of course. That would make our lives easier, but trying to keep our values to 4 significant figures, or even 4 decimal places if it's possible, so that we at least don't exaggerate on the accuracy of our solution or overdo it. So now if we do that, we are going to get a 2.907p for the first P. And for the second term, where we have a minus 2,000, multiplying with that, we are going to get all these other terms. So it is also a good thing to group like terms. So I shift the minus 0.5p closer to the 2.907p so that we are able to deal with the p, and all the other terms are just kept by themselves and they're negative because they were subtracting. So with that, then we shift all these other terms that are not multiplied by a p to the right hand side because we are now solving for the p. So if we do so, we are going to get $8,115.42 on one side, and on the p side, which is the left hand side, we are going to get 2,407p. But of course, this is not the final answer because we have to find what p is. So dividing throughout by 2,000, rather 2.407, that's not 1,000, but that's 2.407. We are going to get a p-value of 3,371 as our final answer. So that's how we would solve our question. And remember to subscribe so that you don't miss out on any of our future uploads. Make sure to check out all the other playlists we have so far. They might be beneficial to you, especially if you are a mathematics, statistics, financial mathematics student. And of course, I'll leave you with the following task. Find a question and post it on the related topic. Remember once again, your questions, feedback are always welcome here. Subscribe, like, and share so that you don't miss out on any of our future uploads. Thank you for watching Numbers Simplified. Remember, God loves you.